Genetic diseases is something that affects a large portion of our population. And in order to better assist those people who suffer from these diseases, it's best to understand what exactly goes behind the scenes of influencing them, such as chemical agents. Today, that's exactly what I'm going to talk about. To discuss chemical agents, two specific chemicals, and how they affect genetic diseases. To begin with, it's best to understand what exactly a mutation is. So mutation is something that's a permanent change in the nucleotide sequence of DNA. It may occur during replication or recombination, and they're often caused by three major things: base mutation, substitutions, deletions, and insertions. And as you can see in the image here, that's exactly what's going on with these codons. This base substitution, a specific one, which is known as a point mutation, which is simply a single base substitution, can be occurring, changes it completely the nucleotide and pretty much changes its purpose, what it does, which will then eventually lead to a genetic disorder. Same with deletion and insertion. It's basically pretty much affecting the coding in some form, whether it's frame shifting it in a way that will change its entire purpose. So the first chemical we'll talk about is ethylmusulfinate. This is the chemical formula. It is often used as an alkylating agent in studies relating to DNA repair. It acts as a mutagenic, a teratogenic, and a carcinogenic, and it is used in biomedical research. A mutagenic is pretty much something that will cause mutations. It's a very likely, has a large likelihood of actually affecting it and creating it. A teratogenic is something that will affect you in the embryo state, and the carcinogenic is something that will raise your likelihood of developing cancer in some way through the cellular replication and just leading up to a constant replication of these cells, creating a tumor. And for this reason, because it can replicate all these functions, this chemical is used in biomedical research to better research these specific genetic disorders, better understand them, and work for treatment. The same thing can be said for this chemical, that N-methyl N-nitrosourea. This is the chemical formula. It is used in metagenicity and genetic studies, and it is being researched to see if it can have some role in cancer chemotherapy agent, again, an improvement in the treatment. It can act as a mutagen, a teratogenic agent, carcinogenic agent, and an alkylating agent, very similar to the one we discussed previously. So there is controversy regarding this topic, specifically genetic testing, which is pretty much you seeing if you have some sort of risk of genetic disorder in your genome already. There's three major issues surrounding it. It's the issue of privacy. Should others have access to genetic records? And do doctors have the ethical obligation to inform relatives if you have a defective gene? This is pretty important because when we're talking about genes, it's something that will affect you. However, because your genes come from your parents and their own parents from them, it is a risk that they might have as well, because you guys do get your genes from your parents. So for this reason, that's why it might be essential and very important for their health as well, if they are made aware if you have something wrong with your genetics. But this is very controversial because it is breaking your own privacy. You're going to get your records shown to other individuals, which is something a doctor is debated on whether a doctor should do or not. There's also discrimination seen in those who take genetic testing and do come back with some risks that they're seeing, and which this includes the denial of life insurance, health insurance, and they may also be seen to be denied or let go of jobs that they may previously have or have the potential of having, simply just get denied because of the genetic disorder. And there's also an issue of equity. So does everyone have equal opportunity to go through genetic testing? This is more of an issue of economics because the testing, like a lot of things, is expensive. It does require you to have be in a specific economic state, and which is an issue because not everyone has the availability of having this test, which can be very essential for their development of their own disease if they actually have one. So it is debated upon whether it should be made more available to the public, more different areas, not just those who can afford it, but those who might also be needing it, which it's something that is seen throughout many different populations as well, not just the wealthy. And I do have a genuine interest in this subject because I do want to study medicine as they go into college. It's a topic that will become very relevant in my future, specifically if I want to study pathology, which is pretty much the development of disorders. Um, this research that's being done, trying to understand how chemical agents do affect these disorders, is very essential. And it fascinates me because it's very much a way to continue the search for something that will help those who are suffering through improvement in the available treatments that they already have, and just provide them with a way that might improve their lives. Not just them themselves, but those who are already at risk of the disease through genetic means, of course, if inheriting it or some kind. Because if it's in your genes, it's already there. It might affect you eventually. But if you have the treatment, an improved form of treatment, it might even help you later on as it develops or as you already have it. It will affect you eventually. So it's best for the treatment to already be made once it develops worse for you. Well, it's best to have it there even before it gets worse. But this is the best way that you can know possible through research, through all these labs dedicated to this subject. These are my citations. Thank you for listening.